Assalamualaikum. We are from Group 8 presenting about Markov chain model for infrastructure industry. Prediction of urban spatial change. Our group have 4 members. The first one is Yazid Firdaus, second is Zafrul Hakim, third Muhammad Razak, and the last one is Muhammad Aiman. Problem statement. Urban regions are complex and dynamic systems, with land use pattern shifting over time owing to a variety of variables such as population increase, economic development, migration, and regulatory change. These shifts have an impact on the balance of residential, slum, commercial, industrial, and green space. The aim is to create an effective predictive model that can forecast how these various types of land use will change over time, allowing for more informed urban planning and sustainable infrastructure construction. Next is importance of simulation. The first one is understanding complex system. Reason, urban areas are complex systems influenced by multiple factors such as population growth, economic activities, and policy decision. The benefit is simulation like Markov chain model enable planners to analyze and predict how various land use categories interact and evolve over time. The second one is informed decision making. The reason is decision makers require evidence-based insight to implement policies and allocate resources effectively. The benefit that we get is simulation provide quantitative prediction of future scenarios, helping policy makers prioritize investment in housing, industry, or green space. The third one is identifying long-term trends. Reason, urban change occur gradually, making it challenging to foresee long-term outcomes. Benefit is simulation tools predict long-term trend in land use, enabling planners to proactively address potential issues as overcrowding, slum expansion, or environment degradation. The last one is resources optimization. Reason is resource like land, infrastructure, and capital are limited. Benefit is simulation help optimize resource allocation by identifying the most efficient strategy for land use, reducing wastage, and ensuring sustainable growth. Next is simulate Markov chain. We using C++ coding to get the stationary distribution. The result that we get is 0.23, 0.18, 0.14, 0.32, 0.12. And after the 10th step, we get the result is 21.39, 16.60, 13.09, 28.02, 10.90.
Okay, right now we want to talk about interpretation of simulation. Firstly is resident areas. Residential areas tend to either shrink or remain stable over time, often transitioning into industrial zones or slums. This could be due to urban growth and industrial activities encroaching on residential spaces, population changes like rural to urban migration, or housing shortages and ineffective policies that fail to protect residential land. Secondly is slums areas. Slum areas are expanding, taking over residential and green spaces. This growth points to increasing urban poverty, unplanned urbanization, and the rise of informal settlements. It may also be due to a lack of affordable housing and proper infrastructure, forcing marginalized population into these areas. And the third is commercial areas. Commercial areas remain stable or grow slowly, sometimes competing with residential or green spaces. This suggests steady economic activity, with urban zoning regulation likely helping to preserve commercial zones and control unplanned changes. The next one is industrial areas. Industrial areas are expanding rapidly, often replacing residential or green spaces. This growth is driven by economic development and industrialization with a focus on increasing economic output. However, it may raise environmental concerns if not managed sustainably. For the last one is green spaces. Green spaces are slowly declining or transitioning into other land uses, driven by urbanization, population growth, and industrial or commercial development. This raises concerns about environmental degradation and highlight the need for stronger policies to protect and expand green areas.
The table shows the transition matrix and transition diagram. This graph is graph of simulation Markov chain. This graph we obtained from the table.